Washington State University. Go Cougs!
Sometimes in the literature, there's not those measures out there, and then you're in that position of having to create a measure and show that you're using a good measure. And there are some ways for being able to do that. The other thing that you want to be able to do is show that your data can generalize. So when you're done your study, you want to say that my data can generalize pretty well across people and across environments. Now, a lot of our aging research that we do here at the university, and more generally, do you have any ideas of the type of people who might come in to do aging research projects, especially in cognition? So I'm going to test you and look at your cognitive functioning. Any ideas who kind of ends up in our samples? What about education? You think we have a good spread of education? You think there might be?
Probably more educated than more general.
Yep. So we see people who are more educated. What about race? Yep. Yeah, especially in this area, we see predominantly white. And let's see. A lot of times, just because of age, we have a larger percentage of female participants, but we also tend to see a lot of middle class participants. So a lot of our aging research, this is widely, has been on white, middle class, well-educated older adults. Now there has been, a big push to change this because it really affects the external validity. So what is true for white, middle-aged, well-educated adults may not be what is true for lower income or other ethnic groups or people who are not as highly educated. And so one of the things that when you're submitting a grant proposal, you typically have to show that you are going to get a diverse group of participants. Now, one of the things that was recently added, and there's a big push, and this has been helpful to us in this region, is that rural communities are now a diversity. So working with individuals who live in rural areas now can fit that diversity requirement because there's a need to capture more information about that group. Okay, so any questions about the information that I discussed so far? So thinking about any of your projects, is anyone kind of, and I know there's some in my groups that are probably going to be in the position of like putting together some sort of Likert scale to test something, or any of you creating your own measures for anything? Tim, you will be, right? Yeah. So, we just talked about the importance of reliability and validity, right? So that's something that we're going to have to pay attention to. We're not going to be able to test all of that, but we can try and create or use the literature to say, this is a good sort of Likert scale to use, like a 1 to 5 or 1 to 7, or maybe we want to use the percentage of 0 to 100%. So you have to use what's out there in the literature to try to design the best kind of method you can for the research that you're doing. All right, so any other thoughts on that information? Okay. So let's talk a little bit about research design in terms of non-developmental and developmental research. So in non-developmental research, we're looking at examining relationships between factors that may apply regardless of age. So for example, a question about, engaging in brain health behaviors. Are those who engage in more healthy behaviors, are they more active, or do they do better on cognitive tests? Okay, that would be a non-developmental question. Irregardless of age, we're kind of interested in that relationship. But we could change it into something that's more developmental and say those people who are engaging in brain health behaviors now, 15 years later, are they going to have better cognition? Okay, so there we're interested in how the aging process actually affects our data. And that's part of kind of the developmental research design, trying to get at the age effects. So we want to know, are the differences due to some sort of underlying aging process? It could be, the biological changes, the psychological changes, the social changes, but really, can we say that the process of aging itself is affecting our outcomes? Now, there are two ways that we can typically look at age-related questions. We can use cross-sectional and we can use longitudinal designs. And each of these have their own confounds. So cross-sectional designs, one of the things that's really great about those is you can do them very quickly, as long as you can get your participants. But what you would do is, let's say we have a survey, and we would give it to a group of people that are age 20 to 35, 35 to 50, 51 to 65, 70 to 85, and we would do that now, today, and we just find people of all those different ages. So that's what we call cross-sectional. Most of our aging research is done this way because it's easier to do than the other type of design, which is longitudinal. So longitudinal is where we take people and we follow those same people over time, right? And so in 2005, we tested these people in the primary school. Now we're going to test them when they're in secondary school, and then young adults and middle-aged adults. We have some people right now that we've been following longitudinally for 5 years who have been living in smart apartments. So you can see how this research, one, takes a long time to do, right? So if I were interested in middle-aged adults now, and I want to see whether or not, if I can teach them how to be healthier, that decreases their chance of Alzheimer's later on, I would have to follow those individuals for a very long time to be able to get that data. Now, some of the things that can happen when you're doing that is you can have changes in personnel. And if you're using certain measures, that may cause changes in your measures, so they might not be as reliable because maybe the two administrators are doing something a little bit differently. There can be a lot of subject attrition, so you have missing data that you need to account for. You can also have practice effects in your data. One thing that we've had in one of our studies, a lot of times to mitigate practice effects, what people will do is they will create two versions of the same test. And those versions of the same test are supposed to be identical, but they're not always identical. And sometimes, like, having those two versions, I think, can be worse than actually looking at the practice effects and trying to control out the practice effects if they're not equivalent. So one of the things that longitudinal designs allow us to do is talk about age changes, changes that are actually occurring as part of the aging process. But there is a big confound that needs to be disentangled in these types of studies, and that can be measurement effects because of time. So if, I don't know, maybe if I'm looking at some sort of political viewpoint, right? Maybe what people think about terrorism. And then in the middle of me looking at that longitudinally, some huge, terrorist attack happens that changes, a lot of people's views about how they're viewing those things. Then it could be that it's not so much the age effect, but it could be what happened during that time that changed a lot of people's views. So the other thing with cross-sectional research, when we're testing people all at the same time but of different ages, that can be a big confound for our studies, is cohort effects. So let's say I did a survey, asking about people's preferences in music. And I found out that as people get older, they tend to like Frank Sinatra more. Okay, so did I really find an age effect? Did I find something that was related to age? Is it true that as people age, they tend to like Frank Sinatra more? No. probably what I found is a cohort effect, right? People living at different times have different preferences. And so that can affect the data. So when we're doing cross-sectional designs, we really can't say that the effects are due to age changes, but what we're really looking at is differences because of age. And let me show you how this can really affect the data. This is a study that was done looking at a verbal meaning test. So they basically gave people a word and said, you know, tell me which words were highly related or it has the same meaning as this word. They looked at the data both cross-sectionally, which is in the squares, and longitudinally, which is in the circles. Now, if you take the cross-sectional data and you look at verbal meaning, what does it seem to be telling you? What happens as you get older with your verbal meaning abilities? They get a lot worse, right? Okay, you see this big decline. But if we look at the longitudinal data, so these are the same people being followed over time, we basically see no decline in verbal abilities. So basically, this is an example of cohort effects. So maybe the questions or the words maybe weren't even around when these people, you know, were younger, so they may not have an idea of what those words were. Or it can also work in the opposite direction. We have a test called the Boston Naming Test that looks at word finding problems. And some of the pictures are things like a yoke. So how many of you, if I showed you a picture of a cow with kind of a yoke on it, would know that it was a yoke? Like, okay, so a few of you. Let's see, what was another one? An abacus. How many know what an abacus is? Okay, a couple of you. But you know, these are things that older adults would be very familiar with, right? But our younger generation may not have the familiarity with. So these are things that are important to take into account when you're trying to look at differences between different age groups. Okay, I think we'll just skip that. This is an example of a very complex design that can be used to help pull apart some of those different cohort and time of measurement effects, where you would start with two different cohorts of ages, 6 and 8-year-olds, say in 2002. You would retest them in 2004 when they're 8 and 10, and now you can start pulling apart some of these different cohort and time of measurements by looking at different aspects of the data. Of course, again, they're very time intensive and costly. Okay, so everyone got the feel between kind of cross-sectional and longitudinal, and that difference between if we're trying to look at non-developmental research versus research that's really looking at aging effects. All right, so let's take a look at some different research methods, some of which you guys may be using in some of your studies. So the first one is the controlled experiment. In an experiment, basically what you do is you have a random sample of participants. You manipulate what we call the independent variable, or the IV. And the way that you do that is you create some sort of what you call your experimental group, and then you'll have something to compare it to a control group. And you're going to randomly assign people to the experimental or the control group. And then you're going to measure some sort of dependent variable, which is going to be the same for all groups. And one of the things that you're going to try really hard to do is keep any other confounds or ways of interpreting your data out of the study. So let me give you an example. Okay, this is one of the studies that we did in the smart home. So that's kind of a picture layout of the smart home. And we were interested in giving individuals a more naturalistic task and seeing how they could figure out something that was kind of open-ended and they can do in any way that they wanted. And we asked this question of whether if we allowed them to plan ahead of time, would that improve their performance? Would they make them more accurate and more efficient? Because if you were efficient with this task, you could actually make one loop around the smart home and get everything done. If you weren't efficient, you might be going back and forth between different rooms to kind of get the information that you need. So we took older adults and we randomly assign them to either a planning or a no planning condition. So our independent variable is planning or no planning, and our dependent variables were our measure of how accurate they were in doing everything correctly, and then how efficiently they did it. And I don't remember exactly, well, we didn't exactly do the experiment this way, but let's say we found that older adults in the planning condition were more efficient in the way they completed the task. One of the things that we would have to do is make sure there's no other explanations for our data. Because we randomly assign people, we would hope that their level of education would be equivalent between the two groups. But let's say we just wanted to check that to make sure. And we found out that our individuals in the planning group were all more highly educated than our individuals in the no planning group. Would you still feel comfortable if I interpret the data by saying planning really increases people's efficiency? Would that be a good conclusion? Okay, so what else could be going on there?
It's possible that their education could make them have better cognitive abilities.
Okay, so it could be that it's not actually planning, but it's people who are more highly educated do the tasks more efficiently. So usually when you use the experimental design and you randomly assign people, those things will work themselves out. You won't end up with one group being more highly educated and another group not, but it could. And so those are things that you would want to test to make sure that there aren't other explanations for your manipulation. Does that make sense to everyone? Okay. So that's the experimental design. Now, when you're doing aging research, you actually can't use an experimental design if you're trying to ask questions related to age effects. And why would that be? Could I say, Shri, I want you to be a 75-year-old woman? That's not going to work, right? I can't assign Shri to the 75-year-old group because she's not 75. So we can't randomly assign people and say, you be the younger adult and you be the older adult. So that is going to only allow us to do what we call quasi-experimental design. We can still manipulate the independent variable like we did in the other study, right? In a non-experimental design, we can't do random assignment and we also don't manipulate a variable, but we can still learn important information. So let me show you some examples of that. So let's go back to our AMAP task again. So here, I can't randomly assign people to be older and younger adults. So I can't do random assignment. I've got that quasi-experimental design. But I still can put people in the planning and no planning condition, right? And I still can look at my dependent variables. And I might find out, for example, that older adults who have the chance to plan actually do better compared to younger adults than the older adults who don't have a chance to plan. Okay, so that planning maybe ends up helping older adults more than it helps younger adults, for example. Now, I could also do the same study in a non-experimental design where I'm looking at older adults and I'm also looking at individuals with mild cognitive impairment. So these are individuals who are having cognitive difficulties and may go on to progress to dementia. Here, I, again, can assign participants randomly, but I also don't have any independent variable I'm manipulating. I'm going to put all my participants within a planning condition. Because one of the things, if I try to manipulate a variable here, mild cognitive impairment itself is on a continuum. And maybe I could get all the people who have more significant cognitive difficulties in my planning group and who don't, or who are less cognitively impaired in my other group, and so that could confound my data. I could try and control for it, but maybe what I want to do is just kind of get some information about if people have mild cognitive impairment, does that affect their ability to do this task, and does it affect their accuracy and efficiency? And then that can lead me to ask some additional questions.